Hello explorers, in today's topic we are going to talk about cryptography, and we're also going to discuss about the various features and techniques which are used in cryptography, and we're also going to explore the reasons and possibilities of cryptography and see what are the applications of cryptography in everyday life, and at last we're also going to see why cryptography is so important and what are the features which has made cryptography so much important in today's lives. So without wasting any more time, let us get started. So what is cryptography? Cryptography is the science of protecting information by transforming it into a secure format. This process called encryption has been used for centuries to prevent handwritten messages from being read by unintended recipients. Today, cryptography is used to protect digital data. So what are the types of cryptographies? Basically, there are two types of cryptographies. The first one is symmetric key cryptography and the second one is asymmetric key cryptography. We are going to discuss about symmetric key cryptography in detail now. It is an encryption system where the sender and receiver of message use a single common key to encrypt and decrypt messages. Symmetric key systems are faster and simpler, but the problem is that sender and receiver have to somehow exchange key in a secure manner. The most popular symmetric key cryptography system is DES, better known as data encryption system. It is also a public key cryptography. So what is public key cryptography? In public key cryptography, both the sender as well as the receiver has the same key. The public key also made available to all the receivers via the sender, and because of this it is very vulnerable to be attacked by a hacker or a middleman, and it can also lead to variable loss of information. So basically we have another type of cryptography better known as hash functions. It is not as popular as the types of cryptographies which I have mentioned before, but in hash functions there is no usage of any key in this algorithm, which is a very big advantage for it. A hash function, a hash value with fixed length, is calculated as per the plaintext, which makes it impossible for contents of plaintext to be recovered. Many operating systems use hash functions to encrypt passwords. So one example has been given here how a hash function works. And finally, the last type of cryptography is known as asymmetric key. Under this system, a pair of keys is used to encrypt and decrypt information. A public key is used for encryption and a private key is used for decryption. Public key and private key are different. So unlike in symmetric key, in asymmetric key cryptography we have two types of keys. One, the public key is known to everyone and the interior receiver can only decode it because he alone knows the private key. So for knowing about the public key and for decryption of the message, we have to know about the private key, which is available with the sender only. It is also known as secret key cryptography. So by far it is the most advanced and safe way of exchange of information via cryptography, and asymmetric key cryptography is the most secure type of cryptography. So what is the classification of cryptography? Basically there are two broad categories of cryptography. First one, symmetric key and asymmetric key, as we have seen. Under symmetric key we have classical cryptography and modern cryptography. Further, classical cryptography has two types, transposition cipher and substitution cipher. And modern cryptography has two types, stream cipher and block cipher. One another concept which is very important, especially in the context of cryptography, is encryption. In encryption, it is basically the process of encoding a message or information in such a way that only authorized persons can access it, and those who are not authorized cannot. So encryption does not itself provide interference, but denies the intelligible content to a would-be interceptor. Also again we have cipher and ciphertext. Basically, in one word, cipher is a coded language of a normally used language in everyday life. So cipher is basically a code, and it is converted form of a normal message like English language or any other language. And finally, the cipher converts the normally spoken language into a cipher text, which is very difficult to be read in the normal form or in the readable form by any user without knowing the key. So encryption algorithm. Encryption algorithm is basically used for encrypting the message into an encryption. An encryption algorithm is a mathematical procedure for performing encryption on data through the use of an algorithm. Information is made into meaningless ciphertext and requires the use of a key to transform the data back into its original form. Some commonly used encryption algorithms are given below. Decryption. Decryption is basically the inverse of encryption. The conversion of encrypted data into its original form is called decryption. It is generally a reverse process of encryption. It decodes the encrypted information so that an authorized user can only decrypt the data, because decryption requires a secret key or password. Key. As we have already known, in encryption or decryption we require a key. So on the broad scale in cryptography, a key is a piece of information or a parameter that defines the functional output of a cryptographic algorithm. For encryption algorithms, a key specifies the transformation of plaintext into ciphertext and vice versa for decryption algorithms. This is basically a flowchart of the whole process of encryption and decryption. It is basically an overview. So as you can see here, we have one sender here and one receiver here. Another interceptor or hacker, you can say, is between the transfer of encrypted form of text to the receiver. So the sender converts the plaintext into an encrypted form using an encryption algorithm, which is further converted into a ciphertext and sent through the medium to a decryption algorithm, which is processed by the receiver, and it is then decrypted, and after decryption the user can get back the plain text form of the message. Here we have another flow chart of the whole process. It is basically the same as before with some pictorial representation, so you can easily understand. Cryptography in everyday life. There is no denial of the fact that cryptography is a very important concept which is being used in every sphere and in every known related sector in our today's lives. So cryptography has wide range of applications in today's lives. The first one is authentication or digital signatures. Quite obviously, we had used ATM facilities or withdrawn our money from our bank account in ATM or any other secure means of transport of cash or digital cash, whatever you can say. So cryptography is very important when it comes to the authentication or digital signature, that is the ATM pin, CVV and account number, date of birth, and all the relevant details which we find in the account of a bank account holder. So without authentication or digital verification, it becomes very risky for anyone to get their cash or their money from their bank account. So cryptography has a very large scale of applications in these sectors. Timestamping. Timestamping is a technique that can certify that a certain electronic document or communication existed or was delivered at a certain time. Timestamping is basically the carbon dating of whether any party has accessed any internet site or any other website or any other video or whatever. Basically, it is used to verify whether a person has actually accessed a particular website or not. So, cryptography also finds its importance in timestamping as well. Electronic money. As I had already said, we live in a world in which the digitalization of cash is being progressed very quickly. So, the definition of electronic money, also called electronic cash or digital cash, is a term that is still evolving. It includes transactions carried out electronically with a net transfer of funds from one party to another. Also, you can say cyber cash, credit card transactions, or any other electronic transaction of cash or Bitcoin or whatever. Cryptography also has its applications in this sector as well. Disk encryption. Disk encryption programs encrypt your entire hard disk so that you don't have to worry about leaving any traces of the encrypted data on your disk. PGP can also be used to encrypt files in case PGP uses the user's private key along with the user supplied password to encrypt the file using IDEA. The same password and key are used to unlock the file. Also, in today's life, we have come across many popular apps that use cryptography and encryption techniques, the most popular among which is WhatsApp, which I believe all of us have used. And these are some of the apps which use cryptography and its related techniques. Here are some more apps and some more. So at last, I would like to say that there are many functions of cryptography, but among them there are 5 primary functions of cryptography. The first one is privacy or confidentiality, which is basically ensuring that no one can read the message except the intended receiver. Second one is authentication, the process of proving one's identity. Integrity, assuring the receiver that the received message has not been altered in any way from the original. Also, number 4, we have non-repudiation, a mechanism to prove that the sender really sent this message. And at last, we have key exchange. It is basically the process by which crypto keys are shared between sender and receiver. So basically, this is all about cryptography in a nutshell. I hope you like the video. If you like the video, please comment, like, share, and also subscribe to my channel for further updates. Thank you.